Good evening, all. Welcome to Infosys Coding Round Training, Day 8. Am I audible? Is my voice clear to you? Just type yes in the chat. If audio is clear, then we'll proceed with today's session. Quickly, can you just reply? Reply in the chat, audio, video. Is it clear? So let us proceed with today's session. Okay, then. So today, I would like to introduce this topic called as dynamic programming. Okay, so hope uh, you are all going to write your exam on 25th January. Okay, so the important topics to be covered. Okay, so in these next 4 or 5 days. Okay, so mainly arrays. I discussed these things in my first video. Okay, so just watch that first video and you will get all the uh, important topics and what are the difficulty levels. Okay, so once again quickly I'm reviewing those topics. So arrays and strings, these topics you need to revise. Okay, so from these two topics you may get a question of difficulty level, easy level. Okay, and the second thing is trees and greedy approach related problems. Okay, so generally these problems will come at medium level difficulty. Okay, so generally questions will be on trees and greedy approach. And the next thing is dynamic programming. Okay, so questions, hard level questions mostly will be of type dynamic programming type. Okay, and graphs questions comes under complex level. Okay, so these are the four questions. Okay, so you will get four questions with each difficulty level, and you need to answer at least three questions. Okay, at most three questions you need to answer. Three questions you need to complete within 3 hours duration. Okay, so in previous videos we discussed uh, questions related to arrays. Okay, so there are many questions we discussed how we can solve problems related to arrays. Okay, so in this uh, session, okay, so we'll try to cover a problem on a concept called as a dynamic programming. Okay, right. So I introduced this concept, dynamic programming concepts, directly with the help of a problem. Okay, so let us go to the problem. Now this is the problem given. You have been given an array of numbers. and you need to find a pair of numbers that are equal to the given target value. Okay, so you need to calculate a pair of numbers. Okay, so whose value is equal to given target value. So you are given a target value, okay, and you are also given an array of numbers. Okay, so then you need to find out this pair of numbers. One pair of numbers you need to find out, or a pair of numbers you need to find out. It can be more than one. Okay, so which satisfy which are whose value is equal to given target value. This you need to find out. Got the problem? Okay. Now let us see. So numbers can be either positive, negative, or both. Okay. So inside the array, you may have positive numbers, negative numbers, or combination of these. Then here he asked, can you design an algorithm that works in order of n complexity? Okay. So that means linear time, which works uh, with a linear time complexity. Okay, so we need to work out algorithm. That means you need to design a solution. Okay, so for this, a simple example, let us take the array is given like this. Okay, so with these numbers 8, 10, 2, 9, 7, and 5. Then the target value is sum is 11. Okay, so now you need to find a pair of numbers whose sum is equal to 11. Okay, so this is the target value given. The target or sum of the pair values is equal to 11. Okay, so from these, if you look at these numbers, then we'll come up with this pair. 9 and 2 forms the pair whose sum is equal to given target value. Yes or no? So directly we can identify from these numbers. Okay, so 9 to 2 9 forms the pair. So this pair we need to identify from this array. It can be anywhere in the array. Okay, it can be anywhere in the array. Even the numbers may not be side by side. Okay, so sometimes the 2 may present here and 9 may be at the last position. Okay, so don't think that they are side by side only. Okay, no, two numbers we need to identify. That two numbers forms a pair whose sum is equal to our target value. This you need to find out. Okay, so first let us discuss this. Okay, so given this kind of problems, generally how we proceed with the solution. Okay, so we look at that solution first. Okay, so let us take this the problem first. Okay, so what is our array? Our array is 8. So what are the numbers? 8, 10, 2, 9. 8, 10, 2, 9, then 7, 5. 7, 5. So this is our array. Okay, so what is our sum? The pair of numbers whose sum should be equal to 11. Okay, so generally when it is given, how our approach, a general approach is like starting from the first number onwards. Then we go on finding another number. Okay, so whose sum is equal to 11. That is what we do. Yes or no? Okay, so that means first I start with the first number. Okay, so first number I'll take as a 8. Okay, so then I traverse the array. I traverse the array. Okay, so then I go on check whether the second number. Okay, so then again I start the array from the beginning onwards. Okay, so from this array again I check whether this 8. Okay, so assume that this is the second number. Okay, so second number may take one by one from this array. Okay, so 8 first number and second number whose sum is equal to 11. No. Okay, so then I'll go to the next number. Okay, so 10 plus 8 is equal to 11. No, then I'll go to the next number. 8 plus 2 is equal to 11. No, then I'll go to the next number. 8 plus 9 is equal to 11. No, then I'll go to the next number. 8 plus 7 is equal to 11. No, then I'll go to the next number. 8 plus 5 equal to 11? No. Okay, so that means with the first number you cannot form a pair whose sum is equal to 11. Then what I do, I'll go with the next number. So I start checking with the 10, whether with the 10 can I form a pair whose sum is equal to 11. Then again I start this array from the beginning onwards. Then I check, okay, so 10 and 8. Okay, so 10 plus 8 is equal to 11? No. Okay, then 10 plus 10 equal to 11? No. Then 10 plus 2 equal to 11? No. Then 10 plus 9 equal to 11? No. Then 10 plus 7 equal to? No. Then 10 plus 5 equal to? No. Okay, so then what I do, I'll go with the next number. Okay, then again I go on checking from the beginning of this array whether there is any number whose sum is equal to 11. Okay, so like this, 2 plus 8 equal to 11? No. 2 plus 10 equal to 11? No. 2 plus 2 equal to 11? No. 2 plus 9 equal to 11? Yes. Okay, so then this is the pair I identified, 2 and 9. I identified the pair. Okay, so this pair we want to find out and the sum of this pair is equal to 11. Okay, so what is given in the find a pair? Okay, so he's asking only one pair in this. Find a pair of numbers that are equal to the given target value. Okay, so that means you should return this. Okay, so then your approach returns the solution like 2 comma 9 or 9 comma 2. It is same. Okay, so we identified a pair whose sum is equal to 11. Yes or no? This is our general approach. This is how we think and we start writing the code. Yes or no? Yeah. So just for naive users, uh, programmers, I am talking about this approach. Okay, so then I'll tell you what is the difficulty with this kind of approach. Okay, so that means the way you think, okay, so sometimes leads you to land with a improper solution. Okay, so that is what I want to uh, convey first. Okay, afterwards how we can rectify the solution with the help of a dynamic programming I'll introduce. Got it? Okay, right. So first, let us write the code for this kind of a solution. Okay, and what is the drawback of that solution? I'll explain. Is that okay? And this solution we call it as a brute force approach. Okay, so we call it as a brute force approach. Okay, so that means there is no particular technique we are using here. Okay, so just we are working with some brute force approach. Okay, so let me change this photograph from here. Okay, otherwise I'll close my video. Let us write a code for this. Okay, so what is our actual array? Well, actual array is something like, okay, so this is our main code. Okay, so array is equal to say something like 8, 10, 2, 9, 7 and 5. Okay, so we want to uh, print the result. Okay, so what we do is we'll directly print the result or the pair. Okay, so just like we call the function as a we want to find pair of numbers, no? So pair of numbers. Okay, or some name you can use for the function numbers. Okay, and for this you need to pass the array and also the target value. So in this case, the target value is 11. Okay, so assume the sum of the pair should be 11. Okay, so this is our main code. Now we need to define this function, pair of numbers function. We need to define. Okay, so here we define the function. Okay, so let us define pair of numbers. So the arguments are array. Okay, so you are getting an array and also its target value, or you can also call it as a sum. Okay, these two arguments you are getting. Array is, this is your array, and the sum value is equals to 11. Okay, so what we do first, in the first case, we, for each number in this array, we need to find out whether there is any other number whose sum is equal to 11 or not. Okay, so that means you need to traverse this array one time. That means you need to use one loop here. Okay, so that means something like a, for first number or something you can use. Okay, say for first number. Okay, so in a array, for first number in a array. Okay, so that means for each number you are trying to search here. Now, so here instead of checking for addition here, the best way is, see, this sum is already given. Okay, so what difference you required here every time? Okay, so say for example, what is the this is the sum value we required. Yes or no? This is the sum value we required. Okay, and the first number is, if it is 8. Okay, so then what is the second number? If you find the difference of these two, then we need to check whether is there a number with this value 3 in this array or not. If there is a number, then it is nothing but the 8 and 3. Combination of these three forms the pair. Okay, so otherwise what you need to do is, you need to perform addition for each number, 8 plus 8, 8 plus 10, 8 plus 2. Okay, so that addition, every time this addition takes one computation time. Okay, so instead of doing this addition for each of these numbers, that means uh, then better you search for a number whose value is equal to difference of these numbers. Just in such case, what happens, it is just like a searching operation. It is just like a search operation, which is faster than this addition operation. Got? This is how you should code, especially when you are writing examinations in online platforms. Got it? Okay, so that technique we will apply here. Okay, so what we do is, we got the first number. Okay, so then we'll try to find out this difference. We'll try to find out. Okay, so we'll take a variable called as difference. Okay, so difference is nothing but, already we know the sum and minus the first number. Sum minus a first number. Okay, so 11 minus 8, 3 is the difference. Okay, so then what you need to do, you need to search in the array whether there is a number 3 present in this or not. Okay, so for that, again you need to run one more loop. Okay, so for second number, just you try to find out for second number in a array. Okay, so for second number in array. Okay, so then you check out. Okay, so what you need to check here, if okay, so and if when you search this number, again you come across with the same number, that means again it starts from the first number onwards. Okay, so your first number is 8, again the second number starts from 8, when same number. Okay, so don't need to calculate the difference or search. Okay, so that's why if the second number not equal to first number, then only you search in the array. That is what you need to inform. Okay, so then you need to just inform here, if the second number. Okay, so you write here, so if the second number, if your second number, okay, so let me take small n here. So if the second number is not equal to first number, then only do this. Okay, you should say then only do this. Okay, so not equals to, then and and what you need to search here, and the second number, if the second number is equal to difference, just checking whether there is a number equal to this difference or not. No, see, we done the subtraction only once. Okay, otherwise for this entire loop you need to perform addition. For each number you need to perform the addition, which is uh, mm, costlier compared to just checking the number. Okay, so sometimes you need to do these kind of calculations, right? So the beauty of this AND operator is, in AND operation, if the first condition is false, it don't go to this second condition. It won't check this second condition. So in our case, what happens? First number is 8, second number is also 8. So 8 not equal to 8, false. Then it don't check this. Okay, so directly it goes to the next number. Got it? Okay, so this is how the AND operator uh, is executed internally. Right. Okay. So then what happens means, whatever calculations we did, it checks. Okay. So it checks for 8, it won't find because there is no 3 in this and a second number here. Okay. So for 10 also, it won't find a second number. For 2, what happens? We'll check here. Okay. So assume that the first number value is 2 here. Okay. So then it finds the difference. What is the difference value? Difference is equal to 11 minus 2, then 9. So it is going to search whether 9 is present in this or not. Okay, so for Sn, second number in array. Okay, so array first, Sn value will be equal to 8. Then it checks 8 not equal to first number. So 8 not equal to 2, yes. And then it checks whether this 8 is equal to 9. No. 8 is equal to 9. No. Okay, so then again the second number takes the next one, 10 it takes. So 10 not equals to 2, yes. And then again it checks 10 is equal to 9. No. Okay, so then it takes the next number, Sn takes the next number. Then 2, Sn value becomes a 2 here. So 2 not equal to 2, 2 not equals to 2 here. So second number is, what is the second number? 2 here. Okay, so 2 not equals to 2, this becomes a false. Okay, so then it goes to the next number, Sn takes the next number, that is a 9 it takes. Okay, so then it checks 9 not equals to 2, yes. Then it checks whether 9 is equal to 9, yes. Okay, so that means we identified a number which is equal to this. So in such case, what you need to do, you identified the pair node, so directly you return the pair. Okay, so you return the pair here, just you say return. Okay, so return the pair here. Okay, so what pair you need to return? First number. Okay, then second number. This is the pair you need to return. Okay, so if you come out from these two loops, after coming out from these two loops, if there is no such pair available, what you need to do? You need to return a pair called as a 0 comma 0. Okay, so this indicates that there is no such a pair. After coming out from this outer loop, you return 0 comma 0. Okay, so this is the simple way of writing this code. Okay, so for brute force approach. Okay, so what is the drawback in this? No doubt it works fine. Okay, so when you execute this code, okay, in our compiler, it works fine for these numbers. Okay, but when you uh, write this code on online platforms, okay, so what is the drawback, that I'll explain. Before that, let me execute this code, whether our code works fine or not. Okay, I'll show in ideally. Let me just execute this code so that you will get some confidence. So let us open this ideally, right? So this is our code. Whatever you can just name it as A, B, first number, second number. Okay, so whatever names you want to use, you can use those names. Okay, so you can just rename first name. Okay, then this is first number, then this is second number. Okay, so second number not equal to first number. Okay, so previously I used these names. Just second number is equal to, okay, so then return the first number and the second number. That's how you can return. But you can use full names. Okay, first number, second number, like all right. So let us run this code, and you can see the pair returned by the code. Okay, so this is the pair returned 2 comma 9. 2 comma 9 is the pair whose sum is equals to 11. Got? Okay, so this is how we returned a pair here. That means our code works fine for given inputs. Okay, right. So let me explain the drawback in this code. So what is the drawback of this code? Okay, right. So generally, when such kind of problems given, okay, so you'll have some constraints given. Yes or no? Constraints given on a number of elements in the array. Yes or no? Okay. So generally n indicates number of elements. Okay. So generally this should be 1 less than or equals to n less than or equals to 10 to the power of 5 something they give. Yes or no? Okay. Right. So this is the constraint. Number of elements in the array should be between 1 to 10 to the power of 5. Okay. So if it is 10 to the power of 5, okay, that means if in worst case, if your array contains 10 to the power of 5 elements, okay, so what happens? And the very first thing is you need to roughly calculate the complexity for these kind of programs. Okay, so you need to understand the complexity of your program. Okay, so here you have two loops, one loop running for the entire array and another loop also running for the entire array. Okay, so if the array size is n, okay, so when you run a loop, then the complexity of that program becomes order of n. Okay, then again you are running one more loop for the entire array size, then it is another order of n size. Okay, so then that means the complexity of your program becomes order of n square. Order of n square. Okay, so which is not a good algorithm, we'll say. But here, what he asked that means you design an algorithm which works in a linear time. Okay, so the algorithm which we designed is quadratic time complex algorithm, we'll say this. Okay, and this algorithm fails. Why this algorithm fails means, now let us understand this. Okay, so we are running the loop two times. For first n, it is we 10 to the power of 5 elements we are running, and inside this we run another loop which runs for 10 to the power of 5 times. Okay, so that means these two loops together, they run for 10 to the power of 5 into 10 to the power of 5. Okay, so which is equals to 10 to the power of 10 times. 10 to the power of 10 times the loops together runs. Okay, so which is generally greater than 10 to the power of 9. Okay, so in competitive programming, okay, so if your code exceeds, okay, so 10 to the power of 9 input size. Okay, so that means it runs for this input size. Okay, so this 10, so if it your input size or program running time is greater than this 10 to the power of 9, okay, so then there is a possibility of getting a TLE, time limit exceeded. Okay, so that means your program never ends. After some time, you will get this TLE error, time limit exceeded error you will get. Okay, so always see that your program input size should not input size should not exceed 10 to the power of 9. It should be less than or equal to 10 to the power of 9. Okay, so these things I'll try to explain in one of the upcoming videos. Okay, so when I prepare a video on competitive coding, okay, so these things I'll explain. Okay, so but for your understanding, I am just giving some knowledge about this time limit exceed, why your code fails. You, if you don't understand these things internally, how the code runs, what is the complexity. Okay, so just to get an idea, I'm just giving these, explaining these things to you. Okay, so that's why you should design an algorithm which works in order of n time only. That means there should not be two loops, nested loops. You should not use two nested loops in this case. Any doubts up to this? Any doubts? Okay, so uh, just whenever you write a code, okay, so try to get the rough time complexity of your code. Okay, so you, for this you require some practice. When you look at some codes, you also think in these lines. Okay, so what is the complexity of that code? And if you practice uh, problems on platforms like lead code, hacker rank, okay, so then you come across such situations. Okay, so when your code fails, okay, even though the logic is correct, okay, but it fails for some test cases. Okay, so you will get them TLE error. Then why you are getting that error, you don't understand. Okay, so if you work out on the same problem, okay, so then definitely you will get some hint in that. Okay, so from those hints you can work out and you can understand why the code fails. Okay, and try to avoid such nested loops in your code. Got it? Right. So having said this, then how to write an efficient code? Okay, for this. So you need to write an efficient code for this. Okay. So for this, what we do is we use an approach called as a dynamic programming. Okay. So dynamic programming is an algorithmic technique. Okay. So in the problem, design an algorithm, he said. Okay. So it is an algorithmic technique which is usually based on a recurrent formula and one or some starting states. Okay, so mainly recurrent kind of problems can be solved by using this DP technique. Okay, so a sub solution of the problem is constructed from previously found ones. Okay, so sometimes what happen means for a given sub problem, okay, so you can identify the solution from previously calculated values. Okay, so that's how the DP technique works. So DP solutions have a polynomial complexity. Okay, so every DP solution will have some polynomial complexity, which assures a much faster running time than other techniques like backtracking or our brute force technique. Okay, so compared to these techniques, DP solution guarantees that your code runs faster. Okay, because it has polynomial time complexity. So it is a way of thinking that breaks down a problem into individual components. Okay, so that means if your problem can be broken into individual components, and each individual component can be solved. Okay, and summing up all such solutions gives the solution to your problem. So this way, if you can think solution to your problem, that is nothing but a DP approach. So the goal of DP solution is to preserve previously seen values. Okay, so previously calculated values, you are not just throwing them out. Okay, so what you are doing, you are preserving those previously calculated values. Okay, and if these previously calculated values are required next time, okay, again you don't calculate directly, you can take them from here and you can proceed further. That is the approach we use in dynamic programming. Okay, so instead of calculating again and again, which wastes time. Okay, so which increases your program complexity. Okay, so if you preserve those values and required in future, directly you can use that value instead of recalculating. Okay, so that is the main goal of dynamic programming. How it can be done, we will see. So the DP problems have these characteristics. The problem can be broken down into overlapping subproblems. Okay, so smaller versions of the original problem that are reused multiple times. Okay, so that means the same problem, a smaller problem occurs again and again. Okay, so that is called overlapping here. Okay, so overlapping the subproblems. Just like, say for example, if you want to calculate a Fibonacci of 3. Okay, so how you will get this Fibonacci of 3? Fibonacci of 3 you can obtain like if you know the Fibonacci of 2 and Fibonacci of 1. Okay, so calculating Fibonacci of 2 is nothing but overlapping. Okay, that means the same kind of approach you are following here. Okay, again Fibonacci of 1, calculating Fibonacci is again it's a subproblem. Okay, so which is performing the same kind of action, overlapping. Okay, so if the problem can be broken into overlapping subproblems, then you can solve that problem by using dynamic programming. Please remember. Then the problem has an optimal substructure. Okay, so that means an optimal solution can be formed from optimal solutions to the overlapping subproblems of the original problem. Okay, now these are overlapping subproblems. Okay, so if you have already stored values for these overlapping subproblems, directly you can use, no need to calculate again Fibonacci of 2 here. Okay, so if you already know these values stored somewhere, you can use that value to Fibonacci of 1. Okay, say for example it is 1, assume that. Okay, so then directly you will get the solution. Okay, so the optimal solutions for overlapping subproblems, if you know them, then you will get by summing up these optimal solutions of subproblems, you will get the solution to the optimal solution to the original problem. Okay, so that is how the dynamic programming problems are formulated. Okay, solutions you can formulate by studying the problem with these two characteristics. If your problem has these two characteristics, then you can apply DP technique there. Okay, so best example of our DP is like a Fibonacci, calculating Fibonacci sequence for a given number, sequence or Fibonacci number in the sequence. Okay, right? So this is how it is given. For example, if you wanted to calculate nth Fibonacci number, f of n you want to calculate. Okay, so how it can be, you can break it into smaller subproblems like finding the Fibonacci for n minus 1 and finding the Fibonacci for n minus 2 term. Okay, so then adding these two gives the result for Fibonacci of the nth term. Okay, so that means if you know the optimal solution of this subproblem, this subproblem. Then adding these solutions gives the optimal solution for the given problem. Okay, so these subproblems are overlapping. Okay, so why it is overlapping? For example, we would need f of 4 to calculate both f of 5 and f of 6. Yes or no? So in f of 5, we need to calculate f of 4 value. In f of 6 also, we need to calculate f of 4 value. Okay, so it is overlapping. Yes or no? Okay, so if you have stored this value somewhere, preserved this value, then no need to calculate here again. So you can use that solution here. Okay, so this is how the dynamic programming approach will be used in solving a problem. Okay, so let us solve our problem using this DP approach. Okay, so DP approach generally dynamic programming. There are two ways of solving this problem. Okay, so one is called as a top-down approach. Top-down approach, and other one is called as a bottom-up approach. Bottom-up approach. Okay, so this top-down approach is also called as a memoization. This technique is called as a memoization, and bottom-up approach is called as a tabulation. Okay, so in top-down approach, what we do, we start with the original problem. Okay, we start with the original problem, then we go on breaking this problem into sub-problems. Okay, so like sub-problem 1, sub-problem 2, sub-problem 3. Then again, we attack these sub-problems and find optimal solutions. Then summing up these gives the solution to the original problem. This is called as a top-down approach. In bottom-up approach, what we do is we'll start with the minimal sub-problem. Okay, then we solve all minimal sub-problems, smallest sub-problems. Okay, so then we go on adding these sub-problems to get the solution to the next level sub-problems. Okay, so like this we go from bottom to up, and finally we reach a solution for the original problem. This is how we'll get a solution for the original problem in bottom up approach. Okay, so today I'll just explain how this top down approach can be used for our memoization. Okay, so generally memoization can be applied to the problems. Generally DP can be used for solving problems which involves recursion generally. Okay, so a problem can be solved by using a recursion. Recursion instance calling a function in itself. Okay, so if the depth of recursion is more, okay, so if the depth of recursion is more, then your problem may hang. Your problem may hang. That means for large input numbers, okay, so the depth of recursion may be huge, and there your problem may hang. Okay, so to avoid this recursion, okay, so we can solve by using a DP. But memoization again still involves a recursion. Okay, so still it uses some form of a recursion along with the caching. That means instead of recalculating the value, okay, so previously calculated values we store, and wherever required for the first time, and it uses the recursion technique. Okay, and the results it stores in some cache memory, and next time when it required, instead of recalculating, then it takes those values from this cache memory. Okay, so this is called a memoization. Okay, so you can, if your problem doesn't require a recursion, okay, so then you can use just a caching and you can get quicker solution to your problem. Okay, so that means you can convert a problem with order of n square complexity to a problem of order of n. Okay, so quadratic time to linear time complexity you can get. Okay, so it is not compulsory that recursion is involved. Mostly recursive kind of problems you can solve with memoization by using caching. Got it? Okay, so how it can be solved by memoization we will see for the same problem. Any doubts in this? Okay, so for our problem, what we do is we'll try to apply memoization technique. This memoization we will apply for our problem. Yeah, let us take our problem. Okay, so then we'll try to use this memoized approach here. Okay, so what was our problem? Yeah, our array is containing the values like 8, 10, 2, 9, then 7, 5. Okay, so we need to find a pair. Okay, so print just we'll say pair of numbers, pair of numbers. Then we need to pass the array and also the sum. This time sum is 11. Assume that 11. Okay, so this function we will define, but this time we use memoization technique. Okay, so let us define this function, pair of numbers. Okay, pair of numbers, then we'll pass array and also the sum. Okay, so this is our function. So previous solution has the time complexity order of n square. Now we convert that into linear time complexity by using the technique called as a memoization. Okay, so here what we need to do is we need to store the previous calculated values. Okay, so what I do is I store something like previous values. Okay, so these previous values I store uh, in a set. Okay, so because duplicate values may present in your array. Okay, so those duplicate values can be stored only once, because that is the previous value we required, or wherever we required we can get it from this set. Okay, so it is better to use a set. If you use a list, what happens, uh, previous values, if there is any duplication, again it will be stored into the list. Okay, so in such cases it is better to use uh, a set here. Okay, so what we do is first we run a loop on this array. Okay, so let me explain the solution here. 8, 10, then 2, 9 and 7, 5. Okay, so this is our array. So for each value we'll try to find out uh, the difference. There is a number whose difference, okay, so is equal to this sum. Okay, like we did in our previous approach. So that means only once you need to traverse this entire array. Okay, so I use a for loop here. So for something like a or b num, some you can take here. Okay, so for a in okay, so array, you can just run the loop only once it is required for a in a array, for each value of the array. Okay, so what I do is first I calculate the difference here. Okay, so difference is equal to sum minus a. Difference is equal to sum minus a. Okay, so then I'll check whether this different value is already present in this previous value. Okay, that is nothing but the second number we required. Okay, so I'll just check here if, okay, so if whether the previous value contains this difference value. Okay, so that means if your diff is in previous values, it is just searching for the value. Okay, so we avoided the addition here. Okay, so if this diff is present in previous values. Okay, so that means we got the second number, so directly you can return. Okay, so you can return the pair here. So the pair is a and the diff. Yes or no? So in previous uh, thing I shown this, here we calculated. Okay, so difference is 3. Okay, so difference, if we find this difference value in the array, that is nothing but that is the second number we identified. Yes or no? So first number is 2, difference is 9. 9 we identified, which is equal to the second number. Okay, so this difference and first number now forms the pair. That is what we are doing here. Okay, so return a and the difference is nothing but the second number. Okay, otherwise for the first time it is not available in a previous values, no, so then it goes to else part here, it goes to else part here. Okay, so then what you need to do, you need to store previously seen value in the set here. Okay, so just I'm writing for you, store the previously seen value. Okay, so previously seen value you store in the set here. Okay, so how you can add a number to this set here, it is nothing but what is our set name, previous values dot add. If you want to add a number to the set, we use the method called as add, and what is that first number, add the first number a. Okay, right, so that's it. So if you come out from the loop, that means you haven't found any pair here, so directly you return a pair called as a 0 0, which indicates no pair. Okay, so this is the simple code. Here we are writing only one for loop. Okay, so that means we are traversing the entire array only once, which indicates the linear time complexity, order of n time complexity. Okay, so how your code runs here, just look at the code here. Okay, so we'll have a set here, we'll have a empty set here, previously empty set. Okay, so this is our previous values. Assume that I have created a empty set previous values. Okay, so when this statement is executed, this is what happens. Okay, so it creates a empty set like this. Then for a in array, okay, so now I'm running a for loop on this array. Okay, so a gets the value one by one. So first a gets the value 8 here. Okay, so then you see here difference is equal to sum minus a. So what is the difference value here? Difference is equal to sum is 11 minus 8, it is 3. Okay, so then it checks if 3 in previous values it is empty. Okay, present no, then it comes to else, then it adds 3 to the set here. 3 will be added to the 3 will be added to the, yeah, is it 3, which one we need to add? Okay, the first number, sorry, the first number will be added because previously seen value, no, from our set. Okay, so this previously seen value we need to add, not the difference, because this is constant value, it never change. So from our set we required a previously seen value. Okay, so 8 will be stored, then a gets the next 10 here. Okay, so then 10 again it calculates the difference here. Okay, so difference is nothing but 10 minus 11 minus 10. Okay, so 11 minus 10 means it is 1 here. Okay, then it checks whether this 1 is in available in this set. No, then it adds this a second number to the set. Okay, so 10 will be added to the set. Okay, so then a gets the next number. Okay, so a gets the value 2 here, a gets the value 2 here, then it finds the difference. So this time difference is 11 minus 2, it is a 9 here. So 9 is present in the previous values, no, so then it adds the next number 2 to the set. Okay, so like this it gets the next number a. Okay, so gets the next number, what is the next number here, 9 it gets. Okay, so 9 it gets, a gets the 9 value, difference is equal to, okay, so it is nothing but 11 minus 9, this is equal to 2. Okay, then it checks if difference is in previous values. Okay, so what is the difference value, 2, whether 2 is present in previous values, yes, it is present in the previous values. Okay, so then return a comma difference. So what is a, our a value is 2 here. Okay, sorry, our a value is 9 here. So what is the difference, difference value is 2. So now this is the pair that is returned here, 9 comma 2 is returned. Got it? Okay, so that means like this it checks for each value of the array. If no pair is found, then finally it returns 0 comma 0. Okay, otherwise if found a pair is returned, see here, only for one iteration on the array you are getting the solution. Okay, so which is order of n time complexity. Okay, now your code works fine. Your code works fine. If you submit your code, then all your test cases and will be passed, and you won't get any TLE also. Okay, so this way you can solve the question. So let us run this code. Okay, so let me just show the execution for this code so that you will get some idea. So this is our code. Okay, so got it? Yeah. So this is our code. So now we are, so caching in the sense what we are doing. This is what a cache, the previously seen values. We are storing the previously seen values. Okay, so with this technique you can get the solution with the order of a n time complexity. That is the advantage here. Okay, so save your code, then run your code. Now when you run your code, you can just see here, you can see here, so you'll get the solution like this. Okay, so 9 comma 2, you got the solution 9 comma 2. And another important point I would like to add here. Okay, so at this point, I would like to add another important point. That means when your uh, expected output is in this form 2 comma 9, and if you return 9 comma 2. Okay, so this is a expected output. This is expected output, and this is your actual output. Actual output. Okay, so even though the pair, okay, so satisfies the target value, some value. Okay, but your expected input and actual expected output and actual output should be in the same format. Same format. Okay, so in this case you will get your test case failed. Okay, so your actual output should be in the same format 2 comma 9. Okay, so to get this 2 comma 9, what you need to do, when you, instead of returning a comma difference, you need to change your code like a return difference comma a, like this, difference comma a. If you return just by slight modification in your code, you will get your actual output in the same format required, which is equal to expected output. Okay, so now your test case gets passed. Okay, so these minute things you should keep in mind. Okay, because many students fail to observe these things, expected output and actual output. Okay, so these things creates a lot of difference. Okay, so sometimes even you can just see here, if your expected output is something like a 2 9. Okay, 2 9, and you are returning like 2 comma 9. Okay, so then also it gives a test case failed. Okay, even extra comma or full point if you keep in your output, which is not as per the expected output format. Okay, so then your test case will fail. Understood? Okay, so these things we should observe. when we execute our code, and when test cases are failed, why those test cases are failed. Mainly you check out expected output and actual output. Okay, so is there any difference in that? If there is any difference, and you can check out if your expected output is 2 comma 9 and your actual output is something like say for example, okay, so from this array you are getting something like 2 comma 7 you are getting. Okay, both are not matching. That means instead of 9 your uh, logic is giving some wrong value here. Okay, so that means there is a error in your logic. Okay, so you need to correct your logic so that it gives the correct output 2 comma 9, 2 and 9 I can say. Okay, so this logic you need to change. These things you should observe very carefully. Okay, so this is the technique called as a memoization. Okay, so in the next video, I'll explain the tabulation technique. Okay, so tomorrow in the next session, we will discuss about another bottom up approach of DP, that is called as a tabulation technique. Okay, so if you master this tabulation technique, then most of hard problems you can solve easily. Okay, so we'll discuss this tabulation technique tomorrow. So that's all for today. If you like this video, and if you think that this is helpful, so please like, share, and subscribe to my channel. So thank you, one and all. You can post your doubts. If you have any doubts, you can just type your doubts in the chat before we end this session. Let me clarify if you have any doubts. Do you specifically require training on some specific topic? Those things you can type in your chat. Okay, then. Thank you, one and all.